Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry mole concept. Come on, let us discuss few more questions from this session. Here the first question for the reaction, 2 moles of ferric nitrate and 3 moles of sodium carbonate gives 1 mole of ferric carbonate and 6 moles of sodium nitrate. Here initially 2.5 moles of ferric nitrate and 3.6 moles of sodium carbonate are taken. If 6.3 mole of sodium nitrate is obtained, then percentage yield of the given reaction. Here, as you observe this reaction, this is displacement reaction. Sodium nitrate and sodium carbonate. Now you observe here the same way. Here, limiting reagent we have to identify. Then finally we can identify the percentage yield. Okay, now here 2 moles of ferric nitrate NO3 thrice plus 3 moles of Na2CO3. It gives 1 mole of Fe2CO3 thrice plus 6 moles of NaNO3. Right. Now here they have given initially 2 moles of ferric nitrate and 6 moles of sodium carbonate. So initially how much moles they have provided? Here 2.5 moles of ferric nitrate FeNO3 thrice. Right. And the same way here 3.6 moles of Na2CO3. Now here we just observe which is the limiting reagent. Now here 2.5. Here what it is? 2.5 moles of ferric nitrate divided by 2 moles of ferric nitrate. 2 moles of ferric nitrate. So that means how much mole it has taken? So 1.25 mole. Right. That means 1.25 moles it has consumed. Initially has taken. Right. Initially has taken this is. Now in the same way this also. Here 3.6 moles. Here actually how much it has taken? 3. So that means here 3.6 divided by 3. Only we observe the reactant point, the number of moles. So here how much you will be getting? 1.20 moles. So which is less consuming. So less consuming it is actually sodium carbonate. So sodium carbonate it is a limiting reagent. So limiting reagent it is what? Actually less amount of consumption. That is called a limiting reagent, right? That means it is completely consumed. So that is called limiting reagent. So the 1.20 when we compare to here 1.25. So naturally 1.2 it is actually lesser than this, right? So limiting reagent is what it is? Sodium carbonate, right? I hope you got the clarity. Limiting reagent. Limiting reagent it is Na2CO3. Got it? Now we have to identify that moles, how much it has produced. So limiting reagent is sodium carbonate. 3 moles of sodium carbonate can produce 6 moles of sodium nitrate. So that is what they have given in the question. Here what it is? If 6.3 mole of sodium nitrate is obtained, then yield the given. So here 3 moles of sodium carbonate can produce 6 moles of sodium nitrate. Therefore here 6.3 moles of sodium nitrate. Right. Now come on, let us check that here. So here let me write that point to you to understand. So 3 moles of sodium carbonate can produce 6 moles of sodium nitrate NaNO3. Therefore 3.6 moles of sodium carbonate can produce how much? So cross multiplication, right? So that means 10 apples cost this much. Therefore 1 apple cost that, like that way. So 3.6 into 6 divided by 3. So you will get how much? 7.2 moles. Right, 7.2 moles. So 7.2 moles you will be getting. So 3 moles of sodium carbonate can produce 6 moles of sodium nitrate. That means 3.6 moles of sodium carbonate can produce 7.2 moles. Right, I hope you got the clarity. So this is 7.2 moles. It is a theoretical value. Right, so theoretical value. Theoretical value, how much moles it can provide when you go for 3.6 moles of sodium carbonate? 7.2 moles. Got it? Now, we have to go for that. What it is? Percentage yield. So, percentage yield, what is the formula you'll be using? Actual yield by theoretical yield. So, actual yield, what it is in the question, what they have given that point, right? Okay, let me write that formula for you. The percentage yield. Percentage yield equal to actual yield. Actual yield divided by theoretical yield. So actual yield, what they have given in the question, I just mentioned, 6.3 moles of sodium nitrate obtained percentage yield. So that is actually what it is, actual yield. So theoretical yield, just now you got the answer, right? Now, can we apply the value here? So here, the percentage they mentioned, percentage means into 100, right? Okay, so here 6.3 divided by 7.2. 7.2, it is what it is, theoretical value, theoretical yield into 100. So how much you will be getting? When you calculate it, 87.5% you will be getting. I hope you got the clarity. How do we identify? This is mainly these questions, whatever we are going to follow, no? These question, upcoming points and all, it is based on limiting reagent. How do we identify? Right now, which is the correct option? Option C is the correct option. Option C is the correct option. Come on, let's go to the next question. The next question, how many moles of P4 can be produced by reaction of 0.10 moles of Ca5PO4 thrice F, 0.36 moles of silica and 0.90 moles of carbon according to the following reaction? Here they have given 4 moles of Ca5PO4 thrice F plus 18 moles of silica and 30 moles of carbon can provide 3 moles of P4 and 2 moles of calcium fluoride and 18 moles of calcium silicate and 30 moles of carbon monoxide. Right, in that they are asking that question, 0.3 moles of here, 0.36 moles of silica can provide 0.36 moles of silica and 0.90 moles of carbon according to that following reaction. They all have asked each and everything. Right, now come on, let us check the reaction. So 4 moles of Ca5PO4 thrice F plus 18 moles of silica and 30 moles of carbon. It can provide here 3 moles of P4, 3 moles of P4 and 2 moles of calcium fluoride plus 18 moles of calcium silicate SiO3 plus 30 moles of carbon monoxide. Right, now here let us check each and everything, like what it is, that is fluoroapatite, silica and carbon. We just observe all that and finally we can identify that limiting reagent also. Right, now here the first point, what it has mentioned here, calcium apatite, 4 moles of calcium apatite can produce 3 moles of P4. Right, so here that 4 moles of, that is fluoroapatite, 4 moles of fluoroapatite can produce 3 moles of P4. Okay, I just mentioned here 4 moles of Ca5PO4 thrice F can produce 3 moles of P4. Therefore, here 0.1 mole of fluoroapatite, 0.1 mole of Ca5PO4 thrice F can provide. So it is like what to say, cross multiplication. So here 0.1 into 3 divided by 4. So how much you will be getting? 0.075 moles according to theoretical value. In the equation what they have given, in the theoretical value what they have given, I just bring that is fluoroapatite. Second point, what it is, silica. So silica, how much? Here silica, here in that silica, in the question, I mean in the equation, 18 moles of silica can provide how much? 3 moles of P4. Therefore, here 0.36 moles of silica. 0.36 moles of silica. See, the same. Just you should get that idea and you should understand the question. So from silica SiO2, it gives what it is, 3.6. 3.6. Now here in the equation, how much they have provided? 18 moles of silica can provide 18 moles of silica, right, capital SiO2 can provide what it is, 3 moles of P4. Therefore 0.36 moles of silica. Right, so how much it can provide? So the same, what to say, cross multiplication. So that means 0.36 into 3 divided by 18. So how much you will be getting? 0.06. So from theoretical value silica, how much you are getting? Moles, 0.06 moles you will be getting theoretical value. And finally, what it is from carbon? From carbon also the same. Carbon, how much? It is 30 moles of carbon can provide how much? 3 moles of P4. Okay, so the same idea, you just bring that. What it is? 30 moles of carbon can provide 3 moles of P4. Therefore, here how much in the question? 0.90 moles of carbon can provide how much? The same cross multiplication here, 0.90 into 3 divided by 30. So how much you'll be getting? You'll be getting around same 0.09 mole only. P4 everything. So from carbon this is 0.09 only mole. So which is that less amount of consumption? So in that, which is that less amount here, 0.06, here 0.09, right? Here 0.075. So that means here, which is that less consumption in the question according to that. Okay, so here 0.1 mole of fluoroapatite, 0.36 moles of silica, 0.9 0 moles of carbon according to that following reaction. How many moles of P4 can be produced? So here, which is that limiting reagent, completely consumption. So that is the way we can bring the answer. So that means here, silica, it is the least amount comparatively others. So that means 0.06 is the correct answer for it. Right, I hope you got the clarity. So actually, according to the following reaction here, the first answer here, 0.06 is the correct option. All right, other questions, other answers and all. Actually, this is for what it is. This answer, it is equivalent to fluoroapatite, but which is the less consumption. That is only the answer we require because this is related to limiting reagent. I hope you got the clarity. Actually, in the question, they did not ask completely which is the limiting reagent, but indirectly they are asking that limiting reagent. We have to understand, right? I hope you got the clarity. Come on, let's go to the next question. The next question, some older emergency oxygen mask contains potassium superoxide, KO2, which reacts with carbon dioxide and water present in exhaled air to produce oxygen according to the given equation. If a person exhales 0.667 gram of carbon dioxide per minute, how many grams of potassium oxide, okay, are consumed in 5.0 minutes? Right now here, they are asking that given mass, right? How many grams of superoxide, that is potassium oxide, are consumed in 5 minutes? Okay, 5 minutes, how much given mass is taken for what it is, potassium oxide. Come on, let us identify very clearly here. The first point, let me write that equation. 4 moles of KO2 plus 2 moles of H2O plus 4 moles of carbon dioxide. It gives 4 moles of potassium bicarbonate, CO3, plus 3 moles of carbon dioxide. Right now here in this point, what we have to observe, mass of carbon dioxide, right? Let us identify the mass of carbon dioxide. Here how much they have provided? Here 0.667 gram of carbon dioxide per minute it has mentioned. So mass of carbon dioxide, mass of carbon dioxide here 0.667 gram per minute. So how much time taken? So time taken, it is 5 minutes, 0 minute. Right, now total mass of carbon dioxide. So total mass of carbon dioxide equal to 0.667 into 5 minutes. 5 minutes. This is gram per minute. That is 5 minutes. So you will get the answer when you calculate 3.335 grams. So total mass of the carbon dioxide this. Now carbon dioxide mass we have observed. Now can we identify the number of moles, because given mass by molecular mass. Okay, so number of moles of carbon dioxide. So given mass by molecular mass. So molecular mass. So given mass how much is 3.33 we can take divided by molecular mass of carbon dioxide. You know very well that is 44 gram per mole. This is gram. So can we cancel this gram and gram? So how much you will be getting number of moles of carbon dioxide? When you calculate it, you will get how much? 0.07578 mole you will be getting. So number of moles of carbon dioxide, you got it. Now molar mass of, you have to identify potassium oxide. So molar mass of KO2, it is actually 71.10 gram per mole, right? Gram per mole, right? That means mass of, now they are asking in the question, mass of that potassium, what it is, how much given mass, right? So given mass of potassium oxide, that is what they are asking. So here how do we identify here moles into molar mass. Can we identify in that way? Moles into molar mass. Moles into molar mass. Molar mass, right? Molar mass. Here moles, how much for the carbon dioxide we have taken? Here 0.07578, because we are getting, that is the way. See here carbon dioxide, it is exhaled, right? So here 4 moles of potassium oxide can produce 3 moles of carbon dioxide it produces. So there here moles and the molar mass only we can bring it out to get that amount of that means given mass of potassium oxide. So here 0.07578 into 71.0, that means 10, right? 10. Right now you will get the answer 5.388 grams. So this is given mass of potassium oxide. I hope you got the clarity. How do we identify? So this is actually, this is the answer. So the given mass, I just mentioned here, given mass of potassium oxide, it is 5.388 gram. That means 5.4 in that way. All right. Yeah, come on. Let us check the answer. 5.38. Yes, we got it. 5.38. The option D is the correct option. I hope you got the clarity. How do we identify? Come on, let us go to the next question. Next question, mass of N2F4 produced by the reaction of 2.0 gram of ammonia and 80 gram of F2 has 3.56 gram. What is the percent yield? Here 2 moles of ammonia plus 3 moles of fluorine, it gives 1 mole of N2F4 plus 6 moles of hydrogen fluoride. Now let us check which is the correct option. Here the same limiting reagent, that point only we can consider. Then we can find out that percentage yield. That is first question we observed now the same idea. Here first and foremost let us identify that number of moles of each compound, right? Here what it is, 2 moles of ammonia combined with 5 moles of fluorine F2, it gives N2F4 plus 6 moles of hydrogen fluoride. Now here number of moles of, they have given what it is, 2 gram of ammonia and 80 gram of fluorine. Right now that means we can identify the number of moles of each. Okay, so molar mass, let us identify molar mass of ammonia, right, and F2. So ammonia and F2, what it is? Ammonia, it is easy, 17 gram per mole. Number of times you have observed, right? Now fluorine, it is 38 gram per mole, right? And the same way, next one, N2F4. So N2F4, how much? 104.02 gram per mole. Right. Now we found all the molar mass of ammonia, molar mass of fluorine, right? Molar mass of N2F4. Right now, number of moles, it will be easy for us. What is that number of moles? Given mass by molecular mass. Given mass, we can take it what it is. Here they have given mass, right? I hope you got that idea. Given mass, they mentioned ammonia and fluorine, right? So number of moles equal to, so number of moles of ammonia, NH3, and the same way number of moles of what it is, fluorine. So number of moles of ammonia, how much? Given mass by molecular mass. Given mass, what it is? Here 2 gram divided by molar mass of ammonia, 17 gram per mole. So you will be getting, so this and this will be cancelled. So you'll be getting how much? 0.1174 mole, right? And the same way here 80 gram. So 80 gram divided by molar mass of fluorine, 38, right? So 38 gram per mole. So 38 gram per mole, this gram and gram will be cancelled. So how much you are getting? 2.1053 mole. So this one, it is fluorine, and ammonia, how much is 0.1174. So which is that less consumption, which is least amount, that is ammonia. So limiting reagent is what it is? Limiting reagent, it is actually ammonia only. Ammonia, it is a limiting reagent. I hope you got an idea what is it limiting reagent. Completely consumption, that means least amount, that means it is completely dissolved in that way. So here now we have to identify the yield. Right now the yield means result, percentage yield. So 2 moles of ammonia yield 1 mole of, see in the equation, see here 2 moles of ammonia can yield 1 mole of N2F4. Therefore, so here we will get that theoretical yield. Okay, then actual yield in the question they have given. No, that way we can identify. So according to the balance equation, here 2 moles of 2 moles of ammonia yield 1 mole of N2F4. So here balanced equation, in the balanced equation, as I mentioned, so therefore here how much we have got that moles. So 0.1174 we got it now, divided by number of moles here too. So you will be getting 0.0587 yield, that is mole. So mole, that is number of moles, yield, that is this is actually a theoretical yield. So we can identify the theoretical yield. How do we identify? So we can identify the mass of N2F4. We can identify. So through that we can identify what it is, percent yield of that. Right now, mass of N2F4. So mass of N2F4, how much? Here moles into molar formula. I mean molar mass. Okay, so moles, how much moles you are gaining here? 0.0587 into molar mass. Already we found, no, that is 104.02, right? 0.02 gram per mole. Right now here how much you will be getting mass, that means given mass. So this you will get 6.107 gram you will be getting, that is given mass. Okay, now theoretical yield, how much? This is theoretical yield, how much you will be getting? This one. Now percent yield, percent yield. Like first question we have observed the same. So actual yield divided by theoretical yield. So actual yield in the question they have given in a gram. So here also we found in the gram given mass, but in the question they mentioned in moles, so that we found in a moles. So here they have given what it is in a gram, so we found that given mass, right? I hope you got that clarity. Now given mass, how do we identify? Here moles into molar mass. I hope you got the clarity. Right now this is actual, right? Actual yield divided by theoretical yield. Yield into 100. Okay, now so can we apply the value here? So what are the values here? 3.56, no? 3.56 gram divided by 6.107 gram into 100. So what is the answer? You will be getting percentage yield, right? So that's what 100. So you'll be getting how much? 58.3 percentage. So percent yield, it is this much. See, in the first question, number of moles they mentioned, but here they mentioned in grams. See, grams, if they are giving, also you can identify through that number of moles. Here, what are the points we have identified? This is a compound, right? So number of moles we can identify. So that is given mass by molecular mass. Then finally, we again we have 2 moles of ammonia yield. What it is? 1 mole of N2F4. So therefore, here also the same, right? So the same idea, we can finally bring the answer. Yes, which is the correct option? Option actually 58.3 percentage, but they did not mention any of the option. This also not there, this also it's not there, this also it's not there. None of this is the correct option. Okay, so which is the correct option? Option D is the correct option. Actually, how much yield it is actually here at percent yield it is 58.3, and which is that here in this point, which is limiting reagent, ammonia, it's the limiting reagent which is less consumption. So number of moles here. So indirectly they are asking all these points. I hope you thorough in all the corner of this question. Right, come on, let us go to the next question. The next question, calculate the mass of lime, that is CaO, obtained by heating 200 kg of 95% of pure limestone, CaCO3. Right now, come on, let us check what is the correct option. Here, CaCO3, when you heat CaO plus CO2. So here, they mentioned what it is, lime by heating 200 kg of 95% pure limestone, right? So that means here what it is, what is the molar mass of calcium carbonate? 100 gram per mole. And the same way, this is 56 gram per mole. So they are asking, calculate the mass of lime here, CaO, obtained by heating. So we have to find out that calcium oxide mass. So here 100 gram per mole can provide 56 gram per mole of calcium oxide. Therefore 200 kg, that is also 95% of pure calcium carbonate, can provide how much of calcium oxide? That's all. Right now here 100 gram per mole can provide 56 gram per mole of calcium oxide. Therefore 200 kg of 95% pure calcium carbonate can provide how much? It is cross multiplication, right? Come on, let us check. So mass of lime, This is purely cross multiplication, like 10 apples cost this much, 1 apple. So this is mass of lime. Here what it is? See, mass of CaCO3 into purity into mass of CaO. Mass of CaO, right? Come on, let us identify the answer. Here 200 kg, right? 200 kg into purity, how much? 95%. No, 95% we can mention it is 0.95 into mass of what it is? CaO. So mass of CaO, here also purity percentage we have to expect. So the 95% means here also you can expect that 95%. So we can write it 56 divided by 100. Is that clear? Why do we apply that 100 over here? Because percentage here also we have to consider. Because here they mention percent, here also we have to mention. So directly I just mentioned 95 divided by 100. I just put it 0.95. So when you calculate this, you will get how much? 106.4 kg. So mass of lime, it is nothing, CaO. So 106.4 you'll be getting. I hope you got the clarity. So this question mark become an answer. 0.6, 106.4 gram, kilogram. Here mentioned the kilogram, right? So here also kilogram. I hope you got the clarity. So which is the correct option? Yes, D is the correct option. D is the correct option. Hope you understand the way you are calculating the answer. Right now, come on, let's go to the next question. The next question. Phosphoric acid H3PO4 prepared in a two-step process. The first step, P4 plus 5O2, you will get P4O10. P4O10 plus 6H2O, you will get 4H3PO4. We allow 62 gram of phosphorus to react with excess oxygen, which form P4O10 in 85% yield. And the step 2 reaction, 90% yield of H3PO4 is obtained. Mass of H3PO4 is produced. Okay, now here actually let us identify the process. Right now here, first one, P4 plus 5 moles of oxygen. You are getting P4O10. So this is actually what it is, oxidation process. Oxidation process. Right. Now the second step, what it is, P4O10 combined with the hydration water. So this is 6 moles of water. You will get what it is, 4 moles of H3PO4. So this is hydration process, right? Hydration process. Right now here in this 62 gram of phosphorus to react the excess of oxygen. Now let us identify the molar mass of P4, P4O10 and H3PO4. P4O10, it is nothing, phosphorus pentoxide, P2O5 only. But here molar mass, that P4O10 only we have to identify. Just I wanted to, you should know that what is P4O10. Right now here molar mass of P4 and P4O10 and H3PO4. Right now here H3PO4 molar mass, you know very well, that is 98 gram per mole. Right now here also P4, what is that molar mass here? 124 gram per mole. Right now here what it is? This is 284. This is 284 gram per mole. Right now, molar mass we found. Now, the next one, number of moles we have to identify. So, number of moles of PO4. Number of moles of P4. Number of moles of P4. How much? Given mass. It is 62 gram of phosphorus. It has mentioned, 62 gram of phosphorus. Okay, so given mass by molar mass. Molar mass. So, that means 62 gram by molar mass of P4. It is 124 gram per mole. So that means gram will be cancelled. So you will get how much? It is 0.5 mole. 0.5 mole. Right now, number of moles of P4, 0.5 mole. Okay, now number of moles of H3PO4. Number of moles of H3PO4. So H3PO4, what it is? P4 into number of atoms. That is moles into number of atoms. So in that way, we can identify that number of moles of H3PO4. So here what it is? Moles into number of atoms. Atoms of P4. Right, now here moles of P4, how much? Moles of P4, here you will get 0.5 moles. The number of atoms 4. So you will get how much here? You will get 2, right? 2 moles. 2 moles. 2 moles of H3PO4. So 2 moles of H3PO4, given mass we have to identify. Given mass of H3PO4. So given mass of H3PO4, this is same. Moles into molar mass. Molar mass, right? Molar mass. So moles into molar mass here, 2 mole into molar mass of H3PO4, 98 gram per mole. See, one similarity for H2SO4 and H3PO4. Both are 98 gram per mole. Please remember. So whenever we relate something, we will not forget, right? Okay, now how much it is actually? 196 gram. This is given mass, no? So gram only you will be getting, not gram per mole. Gram per mole you will be getting for what it is, molar mass you'll be getting. Okay, 96 gram that we have taken. Right now, step 1, what is the percentage they have provided? So step 1, it is actually 85%. Here 85% and here 90%. This is 85% and this is 90%. Okay, come on, let us check with that final mass. Okay, so here, so this is actually given mass of given mass of H3PO4, it is 196. Okay, step 1, it is 85%. Right. Step 2, it is 90%. So how to calculate that final mass? So final mass equal to what it is, 196 gram into 0.85 divided by 100. No, so directly we can convert 0.85 into 0.90. So you will get how much? 149.95 grams. So given mass of H3PO4. So given mass of H3PO4, it's actually 149.95 gram. I hope you got the clarity. Yes, come on, let us check the option. You know the steps how to identify. Okay, here the answer it is 149.95 here, no? So 49, so make it as a 5. So 149.95. I hope you got the clarity. Yes, come on, let's go to the next question. The next question, 9 moles of D and 14 moles of E are allowed to react in a closed vessel according to the given reaction. Calculate the number of moles of B formed in the end of the reaction if 4 moles of G are present in reaction vessel. Percentage yield of the reaction as mentioned in the reaction. Right now here 3D combined with 4A at 80% yield, you will get 5C and 1 mole of A. And the same way here, equation 2, 3C plus 5G at 50%, 6B and 1F, right? Now, we have to identify the percentage yield and moles of B, we have to find out if 4 moles of G is present, right? Now, come on, let us identify the data so that it will be easy for us to identify the answer. 9 moles of D, how much? And 14 moles of E, right? 9 moles of D and 14 moles of E are there in the closed vessel, and calculate the number of moles of what it is, B if 4 moles of G are present in the equation. Right now reaction, right? Okay, so number of moles of B we have to identify if 4 moles of G present. So that is what we have to find the question. Now here in that 3 moles of D combined with 4 moles of E, 80%, we will get 5 moles of C and 1 mole of A. And the same way here 3 moles of C combined with 5 moles of G, 50%, you will get 6 moles of B and 1 mole of F. Right now, let us write that equation so that it will be easy for us. So the first equation, what it is, 3 moles of D combined with 4 moles of E, you will get at 80%, 5 moles of C plus 1 mole of A. Equation 2, 3 moles of C plus 5 moles of G at 50%, 6 moles of B plus F. Now actually, what is the question here? If suppose 4 moles of G present in this equation, what is the number of moles of B formed? That is what the question. Okay, one by one, let us identify. Here, 3 moles of D require how many moles of E? 4 moles of E, right? So 3 moles of D require 4 moles of E. Therefore, here 9 moles they have given. So 9 moles of D that require how many moles of E? Shall we go in that way one by one? Right now here, the first one what it is? 3 moles of, I just change, 3 moles of D require 4 moles of E. Therefore 9 moles of D. 9 moles of D. And the question data they have provided now, see here 9 moles of D. So 9 moles of D require how many moles of E? So cross multiplication, 9 into 4 divided by 3. So we will get 12 moles of E. 12 moles of E. Hope you got that idea. How do we go for it? So 9 moles of D require 12 moles of E. And the same way here, actually in that E, how much? 14 moles of E is available, right? 14 moles of E is there, but here 12 moles of E only required. So E is excess, right? D, it is a limiting reagent. Okay, now we have to identify B only. That is what in the question it has given. Okay, now in that question, here one by one let us go. So here 3 moles of D can form 5 moles of C, right? Therefore 9 moles of D can form how much? Now we have to identify C also. So one by one we can go, because everything it is now C also it is there, and B, from there only we can identify all that. Okay, now here 3 moles of D can form, that means can produce how many moles of C? 5 moles of C. 5 moles of C. Therefore here actually what it is, 9 moles of D can form. See here 3 moles of D can provide 5 moles of C. Therefore 9 moles of D can provide how many moles of? Therefore 9 moles of D can produce. So cross multiplication, 9 into 5 divided by 3. So you will get how much? You will get around 15 moles. 15 moles of C. Right. So 9 moles of D can provide 15 moles of C. 9 moles of D can produce 15 moles of C. 3 moles of D can produce 5 only. 9 moles it can produce 15 moles. Okay. So in the equation, what it is? 3D plus, what is that? 80% yield, no? So 3D plus 4E. 3D plus 4E, it can provide 5C plus A. This is what the question. So in that 80%, so percentage yield can be provided. So that means here 3D plus 4E at 80%, 5C plus A. So percentage yield it is 80. So therefore actual C produced, actual yield produced by C, actual yield produced by C. So that means here 15 into how much? 80%, no, 0.80. So you will get how much? 12 moles of C. 12 moles of C. I hope you got the clarity. So 12 moles of C, it is actually in the actual yield. But in the equation, what they have given in the equation, how much they have given? 3 moles of C can require 5 moles of G, right? 3 moles of C require 5 moles of G. So therefore 12 moles of C can require how many moles of G, right? I hope you got the clarity. I will write that also. So the second equation, what they mentioned here, 3 moles of C, here 3 moles of C plus 5 moles of G, it gives 6 moles of B plus 1 mole of F in that 50%. This is the second equation. Now in that here actual yield produced how much? 12 moles. So here 12 moles of C only. You just remember that. Now 3 moles of C require what it is? 5 moles of G. 5 moles of G. Right. Therefore 12 moles of C. Therefore 12 moles of C here only. 12 moles of actual yield, right? 12 moles of C require. So that means 12 into 5 divided by 3. So how much G? It is actually here 12 moles of C required the amount of G. This is G. What we are required, that is G, right? So that means here how much answer you will be getting? 20 moles of G. 12 moles of C require 20 moles of G. Right now here, actually in the question 4 moles of G is there, means here in the question what they are asking, 4 moles of G is there, means how many moles of B is formed? How many moles of B? So 12 moles of C require 20 moles of B. That in the second equation, 3 moles of C combined with 5 moles of G. Actual yield it is 50%. We may get 6 moles of B plus 1 mole of F. So here 4 moles of G. How many moles of B? That is the question. Now here very clearly it has mentioned. So 5 moles of G can provide 6 moles of B. It's formed, right? 5 moles of G can provide 6 moles of B. Therefore, here 4 moles of G. How much it has formed? So 4 into 6 divided by 5 into yield. How much? It is 0.5. 50%, no? So that is 0.5. So you will get what it is? 2.4 moles of B, right? So 2.4 moles of B you will be getting. 6 into 4 divided by 5, and the percentage yield it is what it is, 0.5. So you will get how much? 2.4 moles of B you will be getting. So 4 moles of G can provide 2.5 moles of B for Bengaluru, right? I hope you got the clarity. Yes, which is the correct option, and I hope you got all the ideas. How do we identify? Data are very important while solving the problems, right? You have to write exactly the data, otherwise different data, no answer will be vary. So what is the correct option? Option A is the correct option. So 4 moles of G can provide how many moles of B? 2.4 moles of B, right? I hope you got the clarity. Come on, let's go to the next question. The next question, the chief ore of Zn zinc is the sulfide Zn as galena. The ore is concentrated by froth flotation process and then heated in air to convert Zn(S) to ZnO. That means zinc sulfide to zinc oxide. So 2 moles of zinc sulfide plus oxygen, 3 moles of oxygen, 80% yield. You are getting 2 moles of ZnO zinc oxide plus 2 moles of sulfur dioxide. And the same way here 1 mole of zinc oxide plus H2SO4, 100% yield, you will get zinc sulfate plus water. 2 moles of zinc sulfate plus 2 moles of water, 80% yield, you will get 2 moles of Zn plus 2 moles of H2SO4 plus oxygen. The number of moles of Zn required for producing 2 moles of zinc will be. Right now here, a simple way we would like to, this is like a logical way thinking. Here, see, 2 moles of zinc sulfide can produce 2 moles of what it is? Zinc oxide. And the same way 1 mole of zinc oxide can produce 1 mole of zinc sulfate. And the same way 2 moles of zinc sulfate can produce 2 moles of zinc. Okay, so that means that is equivalent. Here 2 means here also 2. Here 1 means here also 1. So that means 2 is to 2. 2 is to 2. Here 1 is to 1, and then here also 2 is to 2. So that means it is equal. 1 mole of zinc sulfide, that is 1 mole of zinc oxide. So in that way, here everything it is the same. Zn here, Zn(S) is to ZnO. So that means both are equal actually. So 1 mole of zinc sulfide, 1 mole of zinc oxide. 2 moles of zinc sulfide, 2 moles of zinc oxide. So in that way we can identify. So it will be easy for us to identify the answer. So number of moles of here 1 means here also 1 only. So number of moles of zinc sulfide galena. So moles of Zn divided by here they have given no percentage yield, efficiency 1, efficiency 2, efficiency 3. So percentage yield 1 into percentage yield 2 into percentage yield 3, right? So we can identify in that way. So number of moles of Zn, how much starting? 2 only, no. So number of moles of Zn, that is 2 divided by 80%, we can take it as 0.8 into 100%. 100% means what it is? It's just same as it is into 0.8%. So both are actually 100% and 100%. It is 1, right? That is what I didn't mention, right? So 1, if you want, you can put it. So here 80%, 100%, 80%, right? Now here 2. So you will get how much when you calculate it? Here 2 divided by 0.64, you will be getting Right now, when you calculate it 3.125, you will be getting, so 3.125, it is number of moles of ZnS. So number of moles of ZnS to ZnS required, number of moles of ZnS required for the producing 2 moles of Zn. So it is number of moles of ZnS require for the producing producing 2 moles of Zn, zinc. So that means how many actually, what is that exact answer? So 3.125 moles require, right? So 3.125 moles require. So the number of moles of Zn required for producing 2 moles of Zn. So 3.125 is the answer. I hope you got the clarity, which is the correct option. Easily you can identify. This is logical way thinking. The question may be big, but the answer, it is very simple. If you go through twice, thrice the question, you are able to analyze it very clearly. Yes, come on, let's go to the next question. The next question, 0.8 mole of a mixture of carbon monoxide and carbon dioxide requires exactly 40 gram of sodium hydroxide in a solution for complete conversion of all the carbon dioxide into sodium carbonate. How many moles more of sodium hydroxide would it require for complete conversion into sodium carbonate if a mixture 0.8 mole is completely oxidized to carbon dioxide? See, actually, here this is a mixture, carbon monoxide and carbon dioxide. It's a mixture. How much it is? 0.8 mole. So here 40 gram of sodium hydroxide, it is available in the solution, completely converted, that is carbon dioxide, it is completely converted to sodium carbonate, whereas carbon monoxide still yet to convert. For that, how many moles required? For that, the mixture of 0.8 mole of what it is mixture. So we have to identify carbon monoxide, how much it is remaining from the mixture of 0.8, so that easily we can identify how much required moles of sodium hydroxide. Yes, come on, let us check here the reaction, what it is. CO2 plus NaOH, it gives Na2CO3 plus H2O. So this is the reaction. So here balancing equation, Na2CO3 plus H2O, right? Yes, balanced. Now we have to identify number of moles of sodium hydroxide. Right, number of moles of sodium hydroxide given mass by molecular mass, given mass they have provided already. Right now here 40 gram they mentioned, so number of moles of sodium hydroxide. So number of moles of sodium hydroxide given mass by molar mass, right, molar mass. So here 40 gram divided by molar mass of sodium hydroxide, 40 gram per mole. Right now here how much? You will get 1 mole. Right, sodium hydroxide number of moles, it is 1 mole. Right now here in that point, logical way thinking, from this equation, one, this is actually what it is, 1:2, that mole ratio, it is 1:2 mole ratio. Right, so 1 mole of what it is, carbon dioxide requires 2 moles of sodium hydroxide. Therefore here 1 mole of sodium hydroxide reacts with 0.5 mole of, see here this is 1 mole, no? So 1 mole of sodium hydroxide, as we calculate, we are getting, so from the equation it is 1 mole of sodium, 1 mole of carbon dioxide reacts 2 moles of sodium hydroxide, but while calculating we are getting 1 mole of sodium hydroxide. So therefore 1 mole of sodium hydroxide react, I hope you got that idea, 0.5 mole of 5 moles of what it is, carbon dioxide, right? So this is half, this is nothing, half, right? So this is 1:2, right? So this is 1:half, right? So that means sodium hydroxide is 2, means carbon dioxide, it might be half only, right? So that means moles of carbon monoxide, number of moles of carbon monoxide. See, carbon dioxide, this is carbon monoxide, I just wanted to show here. Carbon dioxide, this is a mixture of carbon monoxide plus carbon dioxide. So how much it is mole? It is 0.8. That is what I wanted to separate it. Okay, now here, this is 0.8, right? So number of moles of carbon monoxide. So number of moles of carbon monoxide, how do we identify? Total mixture mole. Total mixture mole, it is 0.8 mole. Right. So in that carbon dioxide, how much? 0.5. So carbon dioxide mole of moles of carbon dioxide, it is 0.5. So then carbon monoxide, that's what I just mentioned here. Number of moles of carbon monoxide. Number of moles of carbon monoxide, it is 0.8 minus 0.5. So you will get how much? 0.3 mole. So 0.3 moles means how much mole require? How much mole require for what? It is sodium hydroxide. That is the question. Right now here, so CO plus half O2, you will get CO2, right? So each mole of carbon monoxide, 1 mole of carbon dioxide, right? 1 mole of carbon monoxide can produce 1 mole of carbon dioxide, right? Therefore 0.3 mole of carbon monoxide, how much it can provide? 0.3 mole of carbon dioxide. I hope you got the clarity. 1 mole of carbon monoxide can provide 1 mole of carbon dioxide, right? 1 mole of carbon monoxide, 1 mole of carbon. The same way, 0.3 mole of carbon monoxide can provide 0.3 moles of carbon dioxide. Here, oxygen, I did not bring it over here. Only carbon monoxide, carbon dioxide ratio only, I just bring it. Okay, now final mixture contains how much it is? 0.5 plus 0.3. You will get 0.8 mole. How much? 0.8 mole of carbon dioxide only. That is what I wanted to mention. So 0.8 moles of carbon dioxide, right? I hope you got the clarity. Now total sodium hydroxide we have to identify. So total sodium hydroxide, how do we identify? Moles of carbon dioxide into moles of sodium hydroxide required. Total sodium hydroxide, that means 0.8 moles of carbon dioxide into moles of sodium hydroxide needed, right? Okay, now that means here 0.8 moles of carbon dioxide into required how much? 2 moles of sodium hydroxide. No, here in the equation 2 moles of sodium hydroxide. So you will be getting around how much? 1.6 moles of sodium hydroxide. So 1.6 moles of sodium hydroxide required. So actually here how many moles actually it has taken for that calculation? 1 mole it has taken. In the calculation, how much it has taken? 1 mole only. No, given mole number of moles of sodium hydroxide, it is 1 mole. But here 1.6 moles it has taken. So that means remaining additional sodium hydroxide, or remaining, I put addition sodium hydroxide. Addition sodium hydroxide, 1.6 minus 1, so you will get 0.6 moles. So how many moles required to complete conversion of sodium carbonate? That is what they are asking from that, what it is, carbon monoxide converted to carbon dioxide, then it has to be oxidized to sodium carbonate, right? That is what they are asking that question. Okay, so 0.6 moles of sodium hydroxide required. So the given mass, sodium hydroxide, now given mass of sodium hydroxide we have to identify. So moles, given mass formula, what it is? Moles into molar mass. Please remember this. So moles into molar mass, 0.6 into sodium hydroxide, 40 gram per mole. So how much you will be getting? 24 gram. This is given mass only, 24 gram. So 0.6 moles of sodium hydroxide. Additionally, we are adding. Why we are adding? Because carbon monoxide converted to carbon dioxide, and then it has to go for what it has react with the sodium hydroxide to form completely sodium carbonate. So how much gram required? Still more, 24 grams. Now, which is the correct option? I hope you got the clarity. Now 0.6 moles adding. Okay, so that means 0.6. So answer it is B. Option B is the correct option. How much gram required? 24 gram. How many moles required? 0.6 moles required. I hope you got a complete idea about this question. See, values may be changing, concept will be same, right? Come on, let us go to the next question. The next question, silver oxide. Here, silver oxide Ag2O decomposes at temperature 300 degrees Celsius, yielding metallic silver and oxygen gas. Here, 1.6 gram of a sample of impure silver oxide yields 0.104 gram of oxygen gas. What is the percentage by mass of silver oxide and the sample, right? This is very simple only. Come on, let us write that equation. Ag2O, right? Ag2O combined with oxygen, right? Oxidation process only, no, decomposes, right? So it decomposes to Ag plus oxygen, right? So this is solid and this is gas, right? This is a PPT, right? This is PPT, right? Now here Ag2, no, oxygen O2. So that means here what it is, 2 Ag2O. Here you will get 4 Ag and 1 mole of oxygen. So here 2 moles of Ag2O. Ag2O can provide 1 mole of oxygen gas, O2, oxygen gas. Now here we have to identify all the molar masses so that it will be easy to identify the answer. So oxygen, molar mass of oxygen. This is very simple, 32 gram per mole. Right now here, the same way here Ag2O, Ag it is 108, oxygen it is 16, and how many here? 2 into 108 plus 16, because here 2 moles, no, so 2 into 108 plus 16, so you will get how much? 231.74 gram per mole. Right now here actually 108 also we can keep, or 107.87 I just mentioned, right? I hope you got that idea. Now mass of oxygen healed, mass of oxygen healed, how much in the question it has given? 104 gram, right? So 104, see here 104 gram of oxygen gas. So here 0.104 oxygen gas, gram, it is actually 0.104 gram of oxygen, right? So now number of moles of oxygen, see here number of moles of oxygen, number of moles of oxygen. So given mass by molecular mass, no, 0, given mass, this is given mass, mass of oxygen healed, given mass 0.104 gram divided by molar mass 32 gram per mole. Right now here this and this will be cancelled. Now which is the answer you will provide? Here 0.00325, 0.00325 mole. So number of moles of oxygen, this, right? Yeah. Now the ratio, what it is in the equation, 2:1. Here 2 moles of oxygen, what it is, silver oxide can give 1 mole of oxygen. That is what, 2:1, right? So here molar ratio, it is 2:1, right? So that number of moles we can bring it in that way. Molar ratio, it is 2:1. So that means moles of Ag2O, moles of Ag2O equal to 2 into 0.00325 mole. Right now, how much you will be getting? 0.005 mole, 65 mole. Right. Okay. Now, next one, mass of pure Ag2O. This is moles of Ag2O, mass of pure Ag2O. So here already they have given, right? So 0, that is moles into molar mass, right? Moles into molar mass. So moles how much? 0.0065 into molar mass 231.74. Here I just mentioned, you know, here 231.74 gram per mole. That is gram per mole. Right now, so what you will be getting? Mass, that is given mass. Given mass, how much you'll be getting when you calculate it? 1.5064 gram. So percentage by mass. So percentage by mass it is here, that is what it given mass by total gram. So here total gram, how much here in the question only they have given 1.6 sample, right? Sample mixture. So this is given mass by sample mixture into 100. So given mass 1.5064 divided by sample 1.6 into 100, right? Everything gram only, right? So you will be getting around what it is, 94.15%. So mass percentage is this only. So mass percentage how much? Mass percentage by mass of what it is, Ag2O. Percentage mass of Ag2O and 1.6 gram of sample how much? 94.15%. I hope you got a complete idea about how do we get this point. Right now, which is the correct option? Actually 94.25 is the correct option. Okay, hope you got the clarity. Come on, let us go to the next question in our next video. Hope you understand all these questions. Thank you for watching.